then, because I'm going to keep time for you. I'll let you know when you get the 5 minute. Are you the next presenter? Yeah. The 5 minute mark, and then I'll count down. And try to leave a couple minutes for questions if you can. Okay. If you haven't signed the form, all right, good. Thanks.
So, hi, my name is Stefan. I'm a software engineer, and I'm responsible for the software development of the Destiny Plus dust analyzer instrument, which is part of the Destiny Plus mission. I'm working on the Institute of Space Systems in Stuttgart in Germany. It's in it's in the south of Germany. The institute has about 150 researchers with different fields of research. For example, astronautics, space stations, chemical propulsion, satellite technology, and cosmic dust. So we heard a lot of about processor in a loop, hardware in a loop, software in a loop. And now I want to give you an overview of about the requirements in a loop approach. Maybe none of you heard about it. Okay. So I want to give you a short overview about the Destiny Plus mission. Then about the challenges and the characteristics of requirement engineering. And then I want to show you the requirements in the loop approach. Okay. So Destiny Plus stands for Demonstration and Experiment Space Technology for Interplanetary Voyage. It's a Japanese mission, and we as a German institute deliver the Destiny Plus dust analyzer instrument. So the Destiny Plus mission is an upcoming deep space mission. It will be launched in, the plan is to launch it in 2022. Mission period is a minimum of 4 years. And it has an ion thruster as a propulsion. And the goal is to do a close flyby at the active asteroid Sephan. And the Destiny Plus dust analyzer is a major part of the scientific payload of the mission. The Destiny Plus dust analyzer instrument is able to measure cosmic dust. That means it can measure interplanetary and also interstellar dust. So it has a high resolution time of flight impact mass spectrometer. And the instrument is derived from the heritage of other dust instruments, like the dust instrument on Cassini, Giotto, Rosetta, and Stardust. And DDA, that's the short term of Destiny Dust Analyzer, will measure mass, velocity, electric charge, and elemental composition. Okay, one slide about Sephan. The Sephan is the parent body of the Geminids meteor shower. It's a B-type asteroid, and what's special about Sephan is the asteroid is active, but the mechanisms are still unknown. The mission goals of Destiny Plus are to do a flyby and to measure the dust ejection, to measure the dust composition, dust distribution, to measure interstellar dust, and we also want to measure interplanetary dust at the Earth environment. Okay. So I'm responsible for the flight software. So the flight software of the instrument has some functionalities. For example, to process the science data. for example, do some compression and onboard analysis, to handle the housekeeping, to communicate with the spacecraft. The software has some interfaces with onboard FPGAs, and yeah, it also has to configure FPGAs, control of the pointing mechanism of the instrument, because the instrument itself can move, and yeah, to handle the mode of the instrument. So the challenges of the development of flight software are we have little reuse, and it's a unique development. The software maintenance is difficult, so we have also a late availability of the final platform. The software is critical for the mission success, and we also have a long development cycle. So that means we have to focus right at the beginning, from the beginning on, we have to focus on requirements engineering. So what's the challenges on requirements engineering? The challenges are often there are missing resources and know-how to specify good requirements. I will show you what it means what good requirements means. That leads to frustration in the project, notably testers. The maintaining is difficult of the requirements itself during the project phases. And there's also a lack of communication within the development team and also to all the stakeholders in the project. So I would like to give you a quote from a paper I found. And it says, finding and fixing a software problem after delivery can be upwards of 100 times more expensive than finding it and fixing it during the requirements and early design phases. So you can see on this chart that when you create a problem on your requirements, it can be very, very expensive in your project. Okay. So what's the characteristics of good requirements? Good requirements means that your requirements are correct, that your requirements are consistent, unambiguous, legible, complete, and testable. So I thought about it, and as a result, I think good requirements are difficult to create manually. So our approach is to do requirements in the loop testing. So we have you see hardware in a loop, software in a loop, and model in a loop. And requirements in a loop can fill the last gap on the development cycle. So we want to verify requirements as early as possible in the project. So our approach has two elements. The first one is to provide a practical and scalable approach to formal requirements. So there's the challenge that formal requirements have to be understandable and precise. And our solution is to use a combination of textual and graphical notation for formalization. So we model textual requirements using readable language templates. And we model state-based complex control logic via state machines. The second element is that the formalization enables an early verification of requirements. That means validate requirement against expectations before developing the system. So you simulate your requirements before you start to write the software. We use a simulation to discover incorrect, ambiguous, missing, or incomplete requirements. And we use randomized stimuli to find incorrect requirements. Okay. So I want to show you our workflow. Step 1, we describe our requirements. So you can see on the first picture how to model textual requirements by using readable language templates. For example, in the first line, it says every 1 second when the current angle of the instrument is smaller than the commanded angle, then the pointing shall be changed, and it shall be changed about 0.5 degrees. So that's the formalization of one requirement. On the next image, you can see how to model state-based complex control logic via state machines. So it's also possible to use some graphical notations to describe your requirements. There are several tools on the market who can do this. We choose the tool Stimulus for our requirements in a loop approach. Step 2. We put our formalized requirements into a test bench. Now we're getting to the step where we can do the requirements in the loop testing. We have some stimuli for the requirements, and we have an expected output of the requirements, an expected behavior. We call it observer. And within this test environment, we are able to simulate our requirements. So it's also possible to import the software itself on the next step. So you are able to verify your requirements against the real software. So you get a complete traceability in your development process. Step 3, simulate and analyze your requirements. You can see a waveform. That's a result of an example of a result of a simulation. You can see the different time steps and the different values of one signal, and that enables the possibility to get to see very fast how your requirements behave. And it's also a good possibility to show this to other stakeholders, and it's a good basis for a discussion. The last step, step 4, discuss and refine your requirements. So the tool itself, the tools are able to detect if there are some consistent problems in your requirements, or if your requirements are not, their requirements are unambiguous, and it can be done automatically. But if the requirements are correct, complete and legible, has to be discussed with your stakeholders. So this enables the possibility to discuss it within the software team, with the project manager, and with the customers, and so on, with all the different stakeholders. Okay. The benefits are you achieve early requirements validation in your project. You increase the quality of your requirements. You increase error detection in the requirements. You improve requirements maintainability, because you can make very fast some changes in the requirements. You can check automatically if your requirements are still correct and consistent. You can share clear requirements among the different stakeholders in your project, and it's also possible to reduce language barriers, especially in international corporations. Okay, so the conclusion. Good requirements are difficult to create manually. Faulty requirements can become very expensive. Formalization enables early verification and validation. Requirements in a loop can reduce failure probability in your project. It can be used for failure investigation. And requirements in a loop is especially suitable for functional requirements, especially for application software, for software with timing behavior, for clear inputs and outputs, and also for requirements for critical software. So, in my opinion, it's not good to simulate all your requirements. For example, when you have non-functional requirements, it does not make any sense to formalize them. Sometimes it does, but not always. But you should focus with the requirements in a loop approach on your critical software parts with timing behavior. Okay, thank you.
Questions? Yep.
Well, since you have already formalized your requirements to a certain degree, are you also considering to using these requirements for further model transformation to actually generate any software?
I don't get it, sorry.
Do you also use your formalized requirements to generate software?
No, not yet. That would be the next step. What it's able is you can generate test vectors based on your requirements. But that's something we already we thought about, which is maybe possible. But then you have the problem that you have one basis, it's your requirements, and you generate your tests based on these requirements and also the software. But so you have to really make sure that your requirements are correct.
Other questions? Nope. Sound like you have a tough job. Thanks. Thank you.